Hello YouTube and welcome back to another video. We're doing once again picoCTF forensic challenges, and we can start off with pcap poisoning. So we should have a pcap file. If we can start with the EXIF tool, and there is nothing interesting here. Before jumping into the Wireshark, we can run strings on it. We see this one string just repeating itself, but if we grab for pico, we get the flag this way, so we don't even need to use Wireshark. So the next challenge is called MSB. So we have an image and we need to find something about it, the flag in it. So I have this image here. We can run like EXIF tool on it, or it can run like strings. There's nothing interesting in that. So if we look at what is MSB, it's a most significant bit. And if we look at tools for MSB decoding or in steganography, I found this tool on GitHub, SigBits, and it has MSB extraction, so we can clone this. We can now, I'm gonna now copy the image here and call it shorter like image.png. Now if we run the tool with -i and the file named -t to extract using MSB and an output file, and we wait a bit, it says done, check the output file, and if we get output, we see this. It's a lot of junk in here, so if we grab for pico, it still outputs the same because it's only one line, so we need to do -o for only magic and do a lot of dots to see after this more. And now we have the full flag here. So the next challenge is called hide. This is even easier than the last one. This is also steganography. So we have also an image here. We can run EXIF tool and we see a warning trailer data. So there's probably another file hidden inside of it. We can run strings, and in the end we see secret flag.png. So we can just instantly run binwalk, go to extractions, and flag this secret, and we have flag.png here with the flag. So I'm gonna screenshot this and then put it in Google Lens, and if we copy this, and after changing the G to 9, we get the correct flag. The next challenge is find and open. So this time we have a zip archive and pcap file. So first let's look at the pcap because we need password for the zip. So in this file we have a bunch of Ethernet connections, and it says flying on Ethernet secret. Is this the flag? Then we go back. It says good, the flag have been splitted. And then it says maybe try checking the other file. So in Wireshark we see that after these packets we have this one different with the size length of 70, and we have this what it looks like base64. So if we copy this and we can put it on CyberChef, and it says this is the secret, and we get the half of the flag. And actually I was a bit stuck on this step because I didn't know what to do with the zip file. I tried to crack it and other stuff like that, but you just needed to unzip it with the first part of the flag. Now you get the flag, the full flag. Okay, and the next challenge is torrent analyze. This challenge is very interesting. So we need to analyze the network capture and find out what file was someone downloaded from torrents. So we have this pcap file. We can open it in Wireshark. I have already done that. So the protocol that torrents use are this PTDHT, so we can look for that only. So how torrents work it uses peer-to-peer. So computers download and upload files to each other, so it's faster. And if we look at all of these packets, we see a lot of these announce peer, get peers, and info hash. So because we need to find what file is it downloading, so we need to look at these info hashes and find the file which corresponds to it. So because I see a lot of the same hashes, so it's probably downloading this one because it asks a lot of people, other computers for it, so it can download more efficiently. So I would guess that this is the file, so we can just copy the summary as text. Then I have already pasted this info hash into Google with quotes to search for its exact match. Also added torrent Ubuntu because it's from Ubuntu torrent. Yeah, and only found a few websites that are not about picoCTF right up. So we can look at this, and the file is Ubuntu, this Ubuntu ISO file without HTML. So if we just add picoCTF around it, it will be the flag. So let's move on. Okay, and the next challenge is way easier. Under steganography challenge, the description doesn't say anything. We just have this image. Can of course run exif tool, nothing interesting. This is steganography. I will run, because we don't have a password, I will first run stag, which is a tool that tries to all of different methods to find hidden information in the image. And at the top we see the flag. This was very quick. Let's move on. Okay, so I'm gonna do a couple of these slot-git challenges. The first one, slot-git intro, and it just teaches us MMLS. We used these tools last video, so we need to find out the length of the Linux partition. So if you run MMLS, we see this is the Linux partition and this is the length. So I'm gonna connect to the server, get this as the answer, and we get the flag. Okay, so now we can do slot-git apprentice. So we just find the flag in the image, like in last video. So we can run MLS. So these have two Linux partitions. The first one is pretty small, but we can still take a look at it. Alright, we don't see any interesting files, so we can take a look at the second one. Okay, and instantly we can see flag.txt, but this means that it's deleted, but there is flag.unit.txt, so we can try to read that. So the same offset, and just add the ID of the file, which is here, and we get the flag this way. So I think this was enough for this video, and I will hope to see you in the next one.